Hey guys. So, as promised, I'm going to go over the practice problems from the first half of the week. Just an update. They are working on fixing my computer. I will for sure have a computer by next week, one way or another. But for this week, unfortunately, we aren't going to be able to do live meets because I don't have a computer. So, anyway, on to quadratics. So for this, it's in vertex form, so I just can pull the vertex straight out of the equation. Just remember that you got to flip the sign of what's in the parentheses with x. As far as the transformations go, since my vertex is at 2, -3, I know that it went right 2 and down 3. I also know that because A is 1/2, that's a compression, which makes it wider. So it's going to look like this. As far as domain and range, domain for quadratics is always all real numbers, and range, because everything's above the vertex, I'm going to say y is greater than or equal to -3. Okay. For this one, for the vertex, I have to use the formula x equals -b/2a. So here's A, B, and C. So that means I'm going to get -8 over 2 times -1, because if there's not a number for A, it's going to be a 1. So that becomes 8 over -2, which is -4. When grading the homework over standard form, I will say that most people, if they made a mistake, it was on the negative for the x. Just so you know. For the y, I take -4 and I plug it into the equation. Usually with these, because I get them from a worksheet generator, the vertex is going to be like a number that would fit on one of these smaller graphs. So if you get a really big number or something, or a really small, like, super negative number, double check yourself, because, Anyway, so I end up with -16 plus 32, which is 16 minus 18, which is -2. So my vertex is the point -4, -2. For writing it in vertex form, here's the outline of vertex form, and then I just put the numbers in. So the x goes with the x, but I flip the sign. The y goes at the end, and then whatever A is goes in front. So to graph that, it's at the point -4, -2, and since it's negative, it's a reflection, so it goes down. Again, domain for quadratics is all real numbers, and the range, everything's below the vertex. So I'm going to say y is less than or equal to -2. So on to the stuff that was new this week, intercepts. So again, with these, to find the x-intercepts, right, you set y equal to 0. And due to what is called the zero product property, that means that each factor is 0. And if it's one step, that's very simple to solve. You're essentially just flipping the sign. Okay, so my x-intercepts are the points 1, 0, and 7, 0. For the y-intercept, I plug in 0 for x. So 0 minus 1, 0 minus 7. So I get -1 times -7, which is just 7. So the y-intercept is the point 0, 7. Remember that intercepts are points on a graph. So they're not just a number. It's a point, an x and a y coordinate. So this one, same thing. I'll set y equal to 0, or plug in 0 for y, I guess, which means that each factor can be 0. So I just flip the signs. X is -6 or x is 5. So it touches the x-axis at the point -6, 0 and 5, 0. For the y-intercept, I'm going to plug in 0 for x, which is going to give me 6 times -5, which is -30. So it touches the y-axis at the point 0, -30. Okay. Again, same thing. 0 for y. And then each factor can be 0. So when I flip the signs, I get -6 and -7. So it touches the x-axis at the points -6, 0, and -7, 0. For the y, plug in 0 for x. And I get 6 times 7, which is 42. So it touches the y-axis at the point 0, 42. Okay. This one is a little bit different because each factor would be a two-step equation. So that means I'm probably going to end up with a fraction, usually, is what that means. So, you know, if I just solve it like regular, subtract 6 on both sides, then divide by 7. I get x equals -6 over 7. And then for this one, add 3. Divide both sides by 7. And I get 3/7. So that means that this particular quadratic touches the x-axis at the point -6/7, 0, and 3/7, 0. As far as the y-intercept, I just plug in 0 for x. So 7 times 0 plus 6. And 7 times 0 minus 3. Anything times 0 is just 0. So it's going to give me 6 times -3, which is -18. So it touches the y-axis at the point 0, -18. Okay, then this last one, when you have one like this, both factors still have to be set equal to 0. Oops. So I'll just get x equals 0, and then 5x plus 6 equals 0, which I have to solve. So subtract 6 on both sides. Divide both sides by 5. X equals -6 over 5. So it touches the x-axis at the point 0, 0, and -6/5, 0. As far as the y-intercept, plug in 0 for x. So that becomes just 0 times 6, and anything times 0 is 0. So it touches the y-axis at the point 0, 0. Anyway, so that's the practice. I know I probably went through it kind of fast, I'm sorry. But the great thing with videos is you can pause and rewind and fast forward, whatever, all those great things. Anyway, there you go.